This section is geometry and measurement. It is an introduction to fundamental concepts and terms. Knowledge of these fundamentals is key to understanding some of the more complex concepts in geometry, and it's also key to scoring well on the SAT. So this is one definition of geometry, defined as the branch of mathematics concerning the properties and relations of points, lines, angles, surfaces, and solids. And by solids, we mean prisms, cubes, pyramids, cones, that sort of thing. So we will be covering area and perimeter and a lot about notation, but we'll first start with these very fundamental ideas in geometry. So we're going to look at the point, line, plane, line segment, angle, and ray. The first three, the point, the line, and the plane, are generally considered to be the building blocks of geometry. The line segment and the ray are kinds of lines, and an angle exists in the real world, but these others do not. These others are theoretical in nature. They're not really tangible. They're what's known as undefined terms, and that is to say they cannot be defined in terms of real-world tangible things. So they have 0 dimensions. There's no measurable thickness or size to any of these, and again, they are theoretical. So we'll begin with point. Now, when you have a point in space, again, there are 0 dimensions, so it's just an indicator of a location. The green dot on the screen has dimension, of course, but it's, again, just indicating some location. So a point is a position or an exact location in space, and we use coordinates to identify its location, typically XY coordinates, and we always refer to a point with a capital letter. Now, if we introduce a second point, these 2 points may be 2 of hundreds or even thousands of points in a field. But if we develop a relationship between these 2 points, we could connect them with something, what some might call a line. In geometry, this is actually not considered to be a line. Okay, a line in geometry looks more like this one, with the arrows pointing in both directions, indicating that the line extends infinitely in both directions. So what we have here connecting points Y and Z is a line segment. So a line segment is, of course, part of a line. It doesn't extend infinitely in either direction. It has 2 endpoints. So a line segment could be defined as part of a line that is bound by 2 endpoints. So this line segment is a one-dimensional thing, all right? It kind of goes up and down, or has kind of a north-south leaning, if you will. So if we introduce a couple other points here, and now develop a relationship between points Z and A, we could connect them like this. This is not a true line because it doesn't extend infinitely in both directions. It's also, of course, not a line segment because it's not bound by 2 endpoints. So this is what's known as a ray. A ray is part of a line that starts at one endpoint and extends infinitely or indefinitely in one direction, as indicated by the arrowhead there. And so we've created a couple of things here now by introducing ray ZA. We've created, for one thing, a second dimension. So now we not only have a north-south orientation, we have an east-west or left-to-right orientation as well. So that is a second dimension. We've also created a vertex. A vertex is a sort of a corner. And the plural, by the way, for vertex is vertices. But the other thing we've created at point Z, beside vertex, is we've created an angle. An angle could be defined as the amount of turn space measured in degrees between 2 intersecting straight lines with a common vertex. Now, if we put in a couple other line segments, AB and BY, we've created a closed shape, or a polygon. And so a polygon, we'll just clean this up a little. A polygon is a two-dimensional closed shape with all straight sides. A polygon has to have at least three sides. So a triangle is a polygon, a square, a rectangle, or as we have here, a parallelogram, which is obviously kind of a leaning rectangle. Octagon, pentagon, hexagon, decagon. Those are all polygons. And so before we get into area and perimeter, let's talk about notation. If you have a line, as indicated here, a true line extending infinitely in both directions, passing through points R and S, you could indicate it like this: capital R, capital S with the double arrowhead line above. Now, because a true line can either go east to west or west to east, you could indicate it with the RS or this way with the SR. S could be first. It makes no difference either way. You could also refer to this line with a lowercase letter, in this case M. So you could call this line RS or you could call this line M. Now here we have a ray beginning with endpoint R. It would be indicated like this. If you tried to transpose this and put the S first, this would definitely be incorrect. And that's because a ray must be notated always with the endpoint appearing first. If this ray points in the other direction, you'd have to indicate it beginning with the S, beginning with the endpoint first, even though your ray indicator above always points to the right. A line segment has an east-west orientation, which could be read east-west or west-east. So you could notate this with an SR or an RS, and it would make no difference either way. Okay, so here we have a standard XY coordinate plane. We're just going to be looking at this for more notation purposes. But if you just take a look at this, you can see you have two lines, one of which is passing through the point of origin V. And the two lines are A and B. Now, if you see an indicator like this with the two parallel lines between the A and B, that's a simple indicator that these lines are in fact parallel. Line A contains point B, which has as its coordinates x equals -4, y equals 0, and point R, where x equals 0 and y equals 4. Line B contains point C. The coordinates for C are -4, -4. The point of origin, which is V, and point G, the coordinates for which are 2, 2. Line A is the same as line BR. Line B is the same thing as line CG. Ray CG is the ray with endpoint C extending infinitely through G. And ray GC is the ray with endpoint G extending infinitely through C. Now, if you see just 4 points listed like this, BCAV, it's most likely indicating a quadrilateral with those vertices, in this case B, C, A, and V. A simple triangle symbol like this is just indicating a triangle that's created by 3 particular vertices, in this case V, H, and G. This symbol indicates perfect perpendicular form, which creates a right angle. So CA is perpendicular to AV, which creates the right angle at point A, angle CAV. If you see a lowercase m just appearing before the symbol for angle, that simply means the measure of that angle. So this is the measure of the angle created by CAV, which is, of course, 90 degrees. That's also indicated by the squared off box at point A, as opposed to a rounded arc. Once you see that, you know you have a true 90-degree angle. So back to the polygon. Here we have, again, a parallelogram. And if we give it some dimension, you can see that the base is 10 centimeters and the sides are 6 centimeters. Now, a height would always be drawn in perpendicular to the base. In this case, the height is given as 5 centimeters. Now, you'll notice that the base, 10 centimeters, is equal in length to the other base, and that the sides are also equal at 6 centimeters apiece. That will become important as we get into angles. But first, we'll just talk about perimeter. Now, perimeter is very simple. It's just the distance around an object, so it's the sum of all sides. So in this case, 10 plus 6 plus 10 plus 6 centimeters, or a total of 32 centimeters. To figure area is simply base times height. Area is always, always, always expressed in squared units. So remember to indicate your answer in squared units. So base times height, in this case 10 centimeters times 5 centimeters. For a total area of 50 square centimeters. So that is the introduction to geometry and measurement. Thanks a lot for joining us.